This is section 7, chain rule, example 5. So, now we're going to talk about exponential functions. It's another one of those functions that we learned about in everything before calculus. And it's an interesting function, but it's not interesting without using the chain rule, which is why we didn't introduce it until now. So the formula for the derivative of y equals any number to the x power. And it can only be a number greater than 0 and not equal to 1. If it's 1, it's just 1. All right. So, and because 1 to any power is still 1. So it's not very interesting to look at. So we're going to use numbers that aren't 1, and it can be anything. It just has to be positive and not 1. So when we take the derivative of that type of function, you write that function, you write the natural log of the base, and then you multiply by whatever the derivative of the exponent happens to be. If it's So A, the derivative of f of x is going to be prime of x. Now if I just use that function, I write that first, so it'll be 2 to the x, times the natural log of the base, times the derivative of the exponent. Now the derivative of x is just 1, so I'm going to leave it off. That's the answer. For B, f prime of x. Again, I write that function, so we have 3 to the negative x, the natural log of the base, times the derivative of the exponent, which is negative 1. That's it. So when you're dealing with exponential functions, it tends to just be, do you know the formula? And if you know the formula, you'll be fine. In part C, g prime of x is going to be the function itself first, so 1/2 to the x squared plus 1 times the natural log of 1/2, right, the natural log of the base, times the derivative of the exponent, which in this case is actually 2x. And you can't do anything with any of that. It's going to look very ugly because you can't simplify these in any way. We're really just stuck with it the way it is. The only thing you might do to make it look prettier is move things around, but it's really just not necessary. For part D, we have the original equation times the natural log of the base times the derivative of the exponent, which is 2t. And that's it.